Okay, hi, good morning, everyone. It's nice to see a couple of people here, more than I expected, actually. And today I'm going to speak about Edge AI, basically. And Edge AI is the promise of AI anywhere, anytime. But I think the big question really is it already relevant for you? And I'm trying to answer that. First of all, Edge AI basically is where edge computing and AI meet, and I'm pretty sure we don't need to talk a lot about AI. Everyone is talking about AI all the time. It's obviously a huge trend. Edge computing is something, I think it's just more of a business term. But basically today, data is created everywhere. I think there are around 85 billion IoT and mobile devices this year alone. But depending on your definition, all kinds of wearables and laptops and other on-premise setups would count into edge computing too. So it's a lot. And you probably know it just being referred to as locally, on the edge, or on device. So basically, whenever we process data where it is produced, on the edge, locally, on device, this is what I would say business people call edge computing. And it's nothing new and it's nothing fancy. It's just something we've seen happening again and again. It's a paradigm shift from centralized computing back to more decentralized computing. And of course, we know the cloud has been and is still growing a lot. Everything is going to the cloud, which is a centralized computing paradigm. And the data is just following the compute. And with edge computing, the compute is following the data, so you keep it on the device. That's basically all that is. So you would distinguish between cloud AI. That's basically all that we've seen when AI came up, the big ChatGPT models all running in the cloud, versus doing it directly on the car, your local computer, a mobile phone. And why do people want to do this? Of course, because then it works when you are offline, which is important when you are mobile or when you're in the car, because sometimes you don't want to share your data. So whenever you want to work with your data on device, it's basically edge computing. Bandwidth still is a problem. Even though we are expanding bandwidth all the time, the data is growing so much faster that bandwidth bottleneck is a real problem for many, many use cases. Whenever you have a network dependency, you cannot guarantee response rates, and real-time typically is not possible. But when you stay on the device, you can aim for real-time. Of course, you have less costs for cloud and for networking. And last not least, if you care, it's also more sustainable. Because if you avoid sending data around unnecessarily, you avoid using energy and thus CO2. You can compare that to buying apples locally from your local farmer versus importing them from New Zealand or something. Getting your data from far away just is less sustainable. But of course, the reality is not edge versus cloud, but the reality is hybrid. And the first one to really have demonstrated this 1.5 years ago was Apple, with Apple Intelligence, because what they did is they had an AI model and a database locally, and whenever the use case was easy enough, they kept the data offline, private, and it was working fast. And if the question was too complex, it would go to the cloud. Of course, in the background, they not only have their own model running on the device, but they also have a local vector database they have developed themselves for themselves. It's, of course, proprietary. So the question really is, how much edge do you need? And there's another fancy term business people have for that, and it's now very popular. It's hybrid AI. I don't think you need it, but basically it's how much of the AI do you want to offload into the cloud, and how much do you want to or can you do on the device? And it depends on, of course, your costs, but also your privacy requirements you have, and your use case, basically. Every mega shift in computing is empowered by enabling technologies. Now, for Edge AI, we are going to look into the core technologies that empower it. But of course, that image is a little bit flawed because in reality, AI is just so much bigger than anything we've seen before that this edge AI trend is still comparatively small. So the two major technologies you need to do edge AI, and at which we will also have a look, are on-device AI models and on-device vector databases. Now, you can always say local edge, or AI models often are called LLMs, or then if they are small and suited for the edge, SLMs, which is basically small large language models, kind of. But that's a little misleading because, of course, this is language models or general purpose models, but there are a lot of other small models that are just more specific. And vector databases often hide behind the term semantic index or vector search. It's still a database. And then, of course, you would need some kind of data syncing whenever you are hybrid, because, yeah, some of the data needs to go back to the cloud or somewhere. Okay, first let's look at AI models. We all know in the beginning there were all those huge foundational models. It's all cloud AI, of course. ChatGPT made it popular. But then last year in spring, I think, the first major small language model came out. And what happened is people noticed that you can have good quality with way less size, which makes it way cheaper and faster. And it kind of broke this tendency of bigger is better, always going bigger and more expensive, and optimizing for, smaller, more speed, and more affordable. Still, those large frontier models everyone is talking about, the costs are skyrocketing, and they burn a lot of power, right? And this is like never ending. What has changed a bit that the model size often is not publicly shared, so we don't really know, only estimates. However, if you're a little bit on the business side, there is a huge problem with cloud costs for making your business model work. And this is called the cloud cost conundrum. And it is indeed, even though this basic slide is from 2021, and it's from Andreessen Horowitz, is still true, and it's fueled by cloud AI. Companies lose tons of money due to cloud costs, and it's hard to make a margin. And this is getting worse and worse. And just 2 weeks ago, there was a Gartner Financial Summit, and what they said is they believe that using AI has the potential to basically eat all of the earnings you make. So this is a problem, which is one more reason why you might consider doing more on the edge, right? And of course, if you care, sustainability is also a big topic because the data center capacity is just growing massively. And 70% of this is due to AI workloads. At this moment, they estimate that a training run for something like a big ChatGPT is consuming the energy of a small city for a year, which is crazy, right? So something to maybe keep in mind. Is it really interesting for you? Well, I think it is, because at this moment, only few can train. So it's, first of all, probably not your playground. And secondly, there's a dependency. If you build on AI at this moment, you are using their APIs, you are using whatever they might have open sourced, you're dependent. And if the next model is released differently, or whatever they do, well, you need to look what you can do then. Also, it's very, very expensive, and someone needs to pay that bill. Those companies will not be just living on funding forever. We've seen a lot of, I would call, thin layer apps appearing when AI was, coming out, huge trends skyrocketing, and some of them very successful for a time. But it's clear that we will see vertical integration, meaning the big players will do everything that's interesting themselves, and they can always do it better and more cheaply. And it's not really defendable because it's a thin layer on top of something valuable someone else built. So probably not a good playground either. And then, of course, you always have the topic, and especially in Europe, of privacy and data security and compliance. You need to be aware, you know, what you can and want to send around, what your risks are, and what it costs you. And again, if you care, the sustainability aspect. So many reasons why you should care about the current market landscape and why you should consider doing more on the edge. Now, of course, what about open source models? Yeah. Okay, that might be an alternative. Open source in AI is a topic of a lot of debate because what the open source licenses were developed for is not what AI models do, right? So you need to check what exactly has been open sourced. Is it model weights? Is it training code? Is it training data? Is it all? Only if it is all, it's really repeatable, and only then it really complies with the definition of open source. Now, I'm not a huge fan of this whole, is this defined as open source because we have an OZ organization behind that that's very strict and has their own agenda. But here it really might matter because you can't reproduce it and you don't know. It's basically partly at least a black box. Then you always need to check the license. We've seen a lot of open source models calling themselves open source that are not OZ compliant open source, that basically have restrictions in their licenses. So read the license. If you choose to use a black box model, you might be liable in many respects. For example, for copyright infringement, or if there's sensitive data disclosed which is in the model which you don't know because you don't know on which data it has been trained, right? And of course, compliance issues if you work in industries like healthcare or automotive. And last not least, the model might give output that's doesn't, you know, that's politically maybe not correct, and you don't want that, and it might hurt you, right? So just be aware of this when you consider using an free open source model instead. For mobile, now you saw the slide, and I'm sure you all have heard of Gemma and Phi3, etc. pp. Those small language models are great, and when quantized, they can work. They're still not tiny, right? And you can just see that even with just 1 billion parameters, which would be one of the smaller ones, you need at least ½ gigabyte of space, probably more. You can do something to get it even down a little bit more, but then you have a lot of accuracy loss. And you also need the runtime memory. So be aware, it's still a lot of hardware requirements you really are facing. That's why on mobile, people often use more specialized models that tend to be smaller, but are just not large language models. They're not general models. They might just be for vision or speech or text classification or something. However, they are smaller and they're faster, and they're typically really good for their task. So think about what kind of model you really need and choose the right one. Okay, latency, of course, smaller models are faster, and of course they need less battery. I'm skipping a little bit about this because I'm seeing I'm running out of time. So of course, you might consider training. I never would consider fine-tuning, but I'll come to that later. And there's something called linear probing. I'm skipping the recap of all the advantages, and we want to quickly look into the second technology. And that's on-device vector databases. I'm sure you all know what a database is, and a vector database is simply just the database for AI. AI models work with vector embeddings, so vector databases work efficiently with vector embeddings. It's used to speed up LLM responses, of course long-term memory, enable multimodal search. You can also enhance the quality and accuracy of a large language model and adapt it to your use case. So if you have a general model and you, for example, have a special company about, I don't know, screws or something, you can give that model all that information and context as vector embeddings by putting those information into a vector database. And so you can basically all those adapted chats you have seen is a combination of a AI model with the data stored as vector embeddings in a vector database. Yeah? That's called RAG, Retrieval Augmented Generation. You need a vector database for similarity search, which is one of the most important use cases as developers you will probably want to do with AI, and to reduce LLM calls, which can bring your costs down. So as I said, retrieval augmented generation is probably one of the use cases you've seen the most of and which you would be most interested in. Okay, quickly skipping over that, so because I really want to go into that vibe coding thing I did. But for your general understanding, to use a vector database, the query comes in, the AI model takes the query and generates a vector embedding. It goes to the vector database, stores with the query embedding, and searches for the nearest neighbors. So what is the most similar vector in that vector space? And that's called approximate nearest neighbor search, and a very popular algorithm for that is HNSW. With the selected near neighbors, there might be some filtering options, etc., pp, because databases try to be helpful in that respect. And together with the metadata, it gives all of that back again to the AI model, which then generates the response. That's all that's happening in the background. Yeah, the combination of vector database and AI models. And sometimes you want to store that generated response embedding for future use, depending on your use case. Okay, so that's the basic of how the vector database in combination with the AI model works. And it sits at the edge between edge computing and AI and databases. So there in the middle, you see the edge vector databases. It's databases that are small enough to work on mobile and at the same time, of course, support vectors. At this moment, you can either use a vector search lib, which is not a database, or basically object box. Some stats on that if you're interested later. So I wanted to check for you how easy is it to do on-device AI if you're maybe not a developer or maybe it's not your major topic. So I went for vibe coding. Because honestly, doing something in the cloud typically is easy. You don't need to take care of so many things. And you have an API and you make an API call and boom, it runs. Working on the edge has always been way more difficult, and I think it still is. So I wanted to do a screenshot searcher app that enables me to basically search through screenshots I take on my phone. This is because the way I work, I typically, when I do a presentation or a paper on my laptop, I do tons of screenshots. And then 2 years later, when I do something again, I'm like, didn't I talk about this? What was that this competitor or this person did? And then I need to find a screenshot again among thousands of screenshots. It's impossible. So I did something like this for my laptop. Now, because I don't want to share the data with, I don't know, what model, also too expensive. Now I wanted to transfer something similar to Android. So, and the beginning was a breeze. OCR, just extracting text from screenshots, which, by the way, works very well. Easy. Semantic search, creating text embeddings, and then, comparing which one are the nearest one. In the vector database, easy. Image embeddings, uploading an image, searching for similar ones, easy. Quality, not like what you see in the cloud, but easy for me to do as a not developer. Categorization with ML-Kit, image labeling, easy. Perfect. Now, of course, what happens? I wanted to do more. Now I thought about object detection, categorization of the search query, and because it was so easy, why not? Well, all hell broke loose. Nothing worked. Then I decided to focus on the text classification, which seemed easy enough. And I thought, why not add one of those classic SLMs, a Gemma model, because you're all Android developers, that would be interesting. Let's see what happened. Text classification. Well, you want a T-flight model typically for Android, and this is something that's not easy to find. I chose Mobile Bird. It's very, very documented, tons of examples, seems easy enough. However, I couldn't find the model. What I found models that do sentiment analysis, and that worked out of the box easy. But there was no T-flight model for categorization like I needed it. I wanted it to use a dbpedia, which then would categorize if you have an apple that it's a fruit. I learned I would need to fine-tune this myself if no one has published it yet. I'm like, oh, no, training, fine-tuning, I can't do that. But then it sounded easy enough, so I thought like, yeah, run a Python script, vibe coding AI, no worries. You just need to do very few things, choose a framework, small classification header. Yeah, and then I have the dbpedia, vocabulary already easy. I learned a lot. It's not running yet. And it ran already a couple of nights and days and whatnot. I'm still working on this, so major fail. And I need to, 1 minute. So my learnings, in case you want to start, expect lots of trial and errors, don't mix the tech stack, always keep a working requirements, do a 1% smoke run before you ever have a full run that takes the whole night. Save checkpoints often, save the architecture separately, etc. So, Gemma. Easy to download the ready-made model, which is a huge relief because just finding the right model is such a hell. You must accept the terms on each related repo. This is something that's good to know because otherwise, at the beginning you don't know exactly why it's not working. It's not recommended to run Gemma on an emulator. I tried anyways, didn't work. Once I had a real device, it was easy. It worked in less than an hour. But to really get it to exactly do what you want, you need a couple of test runs. You need to, adapt the prompt, etc. And you must be aware if, like I was doing today, you do something for learning and you want to share it back, you cannot share the model alongside your code on GitHub because the Gemma licenses restrict that. This is the app I did, and what it does all kinds of searches when I enter a search term, and yeah, basically it compares the OCR search to the semantic search, to the category search, the image search, if I have an image, to the Gemma keywords and to the Gemma summary. And I must say, oh, by the way, this is the full tech stack I ended up using in the end, which I never expected. And last not least, yeah, I must say OCR texts are really great if you are looking to find screenshots, but doing AI yourself on device is pretty easy. It's way easier than expected. Of course, if you're a developer, the code wouldn't probably be what you wanted to see in the end. But yeah, it's great to test, and I'm pretty sure in 6 months we'll see a lot of progress and anyone will be able to code their own Edge AI applications. Thank you. Sorry for taking too much time.